This is Mr. Ashton going through the mathematics numeracy paper for Unit 1 non-calculator intermediate tier paper from the summer of 2018. Okay, so first page says, Maxine is doing a project on shipping. He draws his own conversion graph to convert between nautical miles and miles. We're then asked down here, it says, what is the 50 nautical miles converted into miles? So make sure you go and find the right axes. So this is nautical miles. I'm looking for 50. There's 100, there's 0. So 50 must be this one here. You would get your ruler. Mine. Make sure you use a pencil, because in case anything goes wrong, it's very easy to rub lines out. So there's 50 nautical miles in between 0 and 100. And then come off and read off on this scale. Now you can see there it's exactly in the middle of this scale too. So I need to find what is in the middle between 0 and 115. So what I need to do is 115 divided by 2. Now, not the easiest thing to do off the top of your head, so probably the best way to do it is split it or partition it into its hundreds, tens, and units. Half of the 100 is 50, half of the 10 is 5, and half of 5 is 2.5. Put them back together, we're going to get 57.5, so I need to circle that one there. The question below it, just check you can see it, says, complete the following statement. Now, the first time I saw a question like this, I fell for it. I thought, well, hang on, you can't do that question. It says, complete the following statement. 800 nautical miles is equal to how many miles? Look for 800, and it's not there. You think, well, I can't do it. However, what you are expected to do is go and find a number that you can find that you know goes into 800. So 200, I know, would go into 800 4 times, or 100 would go in times by 8. I'm going to go from 200, just so I'm times by a smaller number, which should hopefully make my life a bit easier. So I can see that 200 is equal to 230 miles. So I'm going to write that statement there. 200 nautical miles is equal to 230 miles. Okay, I'm going to double that to get 400 nautical miles, and I'm going to find that's 460 normal miles. And then I'm going to double it again to get 800 nautical miles, and then double of 46 would be 92, I hope. And then 0 obviously on the end. Miles. So the answer is 920. Okay, question 2. So a standard type of numeracy question here, an awful lot of information. You need to take a bit of time to read these and make sure you try and understand what on earth is going on. So it says, Mr. and Mrs. Blanc have 3 children, Valerie, Theo, and Anton. So the 3 children are relevant, their names. The family is visiting Wales. Valerie and Theo are 14-year-old twins. Okay, that's important. So we know that 2 of them, because they're twins, 2 of them are going to fit the age 3 to 16 category. And then Anton, who's 2, there's only going to be 1 person who fits that 3 category. So it's important to pick that bit out from that information so far. It says, the family decides to pay the standard charges to visit Castel Gwynhir. How much change they get from 20. Now, this is what I'm really bad at doing. When I was doing my model answers before this, I missed that bit there. How much change will they get from £20? I answered the first bit. First bit says they're going to pay the standard charges. So I'm interested in this column here. Okay? So I need to go and work out how much the adults are going to pay. So it's Mr. and Mrs. Blanc up here. So that's going to be 2 adults. So I'm going to do 2 lots of £5.60. 2 lots of 5 are 10, 2 lots of 60p are £1.20, so £10 and £1.20 would be £11.20. It's going to be 2 lots of £2.30, which is a much easier calculation. It's £4.60. And then it's going to be 1 lot of free, so we don't have to pay anything at all. So then adding together the zeros, 2 add 6 makes 8, decimal point, 1 add 4 makes 5, and then 1 add nothing is 1. So we have a total, so we pay £15.60. My change is going to be £20, take away the £15.60. Now, rather than doing this in column subtraction, you can do that if you're comfortable with it. I thought the easiest way to do this, I'm lying here, look, £15.80. £15.80. I always think of it as a journey. If I'm on £15.80, I want to get to 20 quid. Well, if we add 20p, we get up to 16 quid, and then if we add 4 quid, we get up to 20 quid. So my change would be £4.20. Okay. Okay, so the next question says that you will be assessed in this question on the quality of your organisation, communication, accuracy, and your writing. Now, that's only those 2 marks there. 3 is still for the maths. So what I'm going to do is I'm going to write down the maths, and then I'm going to give a little explanation to each step I do. I'm going to include any pound signs, any units at all that I need to. That's all that we need to do for these OCW. You don't need to write a huge essay for them, okay? So it says Theo looks at the charges with a 10% contribution towards improvements. So you can see when we worked on the standard charges, I looked at those. This is the charge with a 10% contribution. Okay, so it then says, Theo says the adult charge with an extra 10% is not right, it's too high. By how much is the adult charge too high? You must show all your working. So in order to do that, I'm going to go and work out, it says 10% contribution towards the improvement. So I need to go and find 10% of that first of all. So I'm going to say 10% of £5.60 is equal to, so we divide that by 10 to get 56p. All I'm going to do now is put an arrow pointing to that and just explaining what this is. So this is 10% of the standard adult charge. Okay, the next thing I'm going to do is add that 56p onto the £5.60. So I'm going to say £5.60, add 56p, 0 add 6, 6 add 5 is 1, 6. Okay, so what was this? This was me adding the 10% charge to the standard charge. I can't seem to write the word charge. There we go. Charge. Actually, as we are assessing the quality of our communication, let's make sure it's clear. It's charge. Okay. Now, you can see that it should have come to £6.16, and actually, we've been charged £6.40. So it's not correct, and the question said, by how much is the adult charge too high? So I need to do £6.40, take away £6.16. Could use the method I used previously, or here, because it is such a nice calculation, I don't have lots of zeros I need to cancel out. I'm just going to use my column subtraction. So 10 take away 6 is 4, 2, 0. So it is 24p too much charged. So Theo was right. Okay. The next thing I'm asked for is part C. Just move the visualizer down here so you can see it clearly. It says the gardens at Castle Gwynhyr cover an area of 714,000 metres squared. Water covers 2/7 of the area of the garden. Calculate the area of the water ponds. Okay, so we're told that water ponds cover 2/7 of this area. So what we need to do is work out how much 2/7 of that is. So we need to find 2/7 of 714,000 metres squared. So to do that, I'm going to find 1/7 by dividing by 7. So I'm going to do 714,000 divided by 7. So counting 7 till you get 7, 1. Counting 7 till you get to 1, you can't. The answer is 0. Remember to cross that out and count it over as a remainder. Counting 7 till you get to 14, 2. And then 0, 0, 0 would come in here as well. 7 doesn't go to 0. So my answer of 714,000 divided by 7 is 102,000. So now I know what 1/7 is. To find 2/7, I do 102,000 times by 2 to get 204,000 metres squared. Okay. Okay, next question. says the tables below show all of the international football results from Wales in 1984 and 1985. We're then asked here for question A. It says, Geraint says, on average, the Wales international football team scored more goals per match in 1985 than in 1984. In checking the truth of Geraint's statement, why would it not be helpful to consider the range of the number of goals scored per match? Well, the simple answer is the range is not a method of the average. There's three averages, which is mean, median, mode. Range just checks the highest, take away the lowest to see the spread of the data. So I'm going to say the range will show the spread of the data between the highest scoring, the highest. Okay. Over the page, it says, by considering the mean number of goals scored per match by Wales each year, is Geraint's statement true? You must show your calculations for each year to support your answer. So, Geraint said, on average, the Wales international team scored more goals. Okay, so I'm going to count the total number of Wales goals here. So total number of goals. They lost that game, but we're interested in goals. So 1, 1, 1, 0, 0, 0. Oh, they had a bad run here. 4 games without a goal, and then 2 goals. So in total, we've got 1, 2, 3, 4, 5. So in total, 5 goals. In 1985, we scored 1, 1, 3, 2, 1, and 0. So we scored 1, 2, 5, 7, 8. So we scored 8 goals. We scored more goals than less games. So yeah, he's absolutely right, okay? So I'm going to say here, yes, Geraint is correct. And then I'm going to work out the mean here. So I'm going to say in 1984, 5 goals in a total of 8 games. I'm not actually going to work that out. I'm going to leave it as a fraction. Was the mean. In 1985, they scored 8 goals. There was 1, 2, 3, 4, 5, 6 games. 8 out of 6 was the mean. They're both averages, and I'm going to say 8 out of 6 is greater than 5 over 8. Okay, now that will get me those marks there. And then part 2, it says, give one reason why this method does not necessarily show that Wales international team results were better in 1985 than 1984. Now, these ones are always fussy. I don't like these ones. There's lots of different answers you can give. I'm just going to go for the one that sort of sticks out to me, which should be, well, these are all about goals scored. That's great if you're scoring goals, but if your defence is rubbish and you're conceding lots of goals, then you don't necessarily mean that your results are better, okay? So I'm going to say only accounts goals scored, not conceded. Okay? There's loads of different answers you could do that. If you check the marks here, there's stuff like doesn't account for injuries and stuff like that. Loads of different things. Okay, then. Question number 4. It says, in the towns of Aberglen, Bargwyn, Carlow and Derwin are on a bus route 3. The bus times, so you can see, the bus times take to travel between each of the towns are shown on a diagram. Okay, so to go from A to B, 10 minutes, from B to C, 30 minutes, from C to D, 20 minutes. We're then asked here, it says, buses start at Aberglen. All of these buses travel to Derwin, stopping at Bargwyn and Carlow. Here is the bus timetable. Departing from Aberglen, first bus leaves at 9 a.m, then every 13 minutes after this time. At what time does the 9:13 bus from Aberglen arrive at Derwin? Okay, so what we need to do is work out how long the entire journey is going to take. So we'd say that's 10, 30, so 40 minutes, add 20 minutes, it's 60 minutes. 60 minutes is an hour. If we leave at 9:13, we'll be getting in an hour later at 10:13. So quite a nice first one there. Dilys arrives at the bus stop at Bargwyn at 9:30. What time is the next bus? Okay, so she goes to this place, Bargwyn, at 9:30. So she's here. Now, we know that leaves at 9:13. It's going to get to Bargwyn 10 minutes later, so at 9:23. And she gets there at 9:30, so she gets there after this time. So she misses that bus there, so she does not get the 9:13 bus. We know that they arrive every 30 minutes after this time, so the next one would be at 9:26. It takes 10 minutes, so 9:36 will be the next one. She got there 6 minutes early. Okay, so 9:36 is the next time that the bus arrives. Okay. So, what question we got next? Part B. It says, from Grainsea, the number 6 bus runs to Windray and the number 7 bus runs to Havgoch. The timetable for these buses is given below. The number 6, first bus leaves at 10, then every 20 minutes after this time. For the number 7, the first bus leaves at 10, then every 45 minutes after this time. After 10, when will the number 6 bus and the number 7 bus next leave Grainsea at the same time? Okay, so what I'm going to do is I'm going to write out the times for the number 6 bus at how regularly it leaves. So the number 6 bus leaves at 10, then every 20 minutes after this time. Okay, so that's going to be 10:20, 10:40, 11, 11:20, 11:40, and so on. Okay, I'm going to do the same for Havgoch, and we're asked when is the next time that they are the same time. So Havgoch leaves 10, 10:45, 11:30, 12:15, 1 o'clock, and 1:45. Now, the one thing I haven't done, I haven't explained how many I've done. I've written the first time that we're told they first meet, so 10 in both, and then I've written 5 out. I'm hoping within 5 we'll have a time that they both meet, but I can see there in my list there's no number apart from the 10 where they meet up again. So what I need to do is go to the smaller one and add a few more there to see if it meets in the big one. I'll do another 5 entries if I can fit them in. If there's still no time, I'll go back and add another 5 entries to that. Okay, so I'm then going to get 12, 12:20, 12:40, and then 1300 or 1 o'clock. I can see it there. So we had the 10 o'clock one, and then those two there. Don't know why I sort of went in between 24-hour clock on one and not the other, but let's make it consistent. So let's make that 13 and 13 there. So after 10, so what time do they meet again? So they leave at 13 o'clock. Okay. All they want to see is that I'm realising to work out these lists here. It's really important to show you working. Okay, question number 5. Take a moment to read it. Again, if you don't read these questions, you'll find it very hard to work out what's going on. It says, Lycan's parents have compiled that they are paying too much money towards his phone bill. Lycan decides to ask a number of his students in the school how much their parents or carers pay towards their mobile phones each month. He displays the results in a scatter diagram. These include his own results. Okay. You can see there's no correlation there at all, so it's not the younger you are, the more that your phone bill accounts for. You would assume it probably did do something like that. However, that's not what these results are showing. It then says, Lycan's parents want to know the names of some of the students. 2 15-year-old students are Harriet and Hilary. Hilary is older than Harriet. So, 2 15-year-old Hilary and Harriet. So I'm looking at 15. So 15-year-old students, I can see there's one of them. And then 16 is the next age, but this age is in between 15 and 16. So those two are the 15 years. So as age gets bigger, so 15, 16, this person is exactly 15, this person is 15 and a bit. So a Larry is older, this is a Larry here. Okay, so that means this must be Harriet. And then we're told here that Gwilym and Alid's parents each pay $27.50. So where's $27.50 on the graph? $25.30, $27.50 will be in the middle. So these 2 points here and here. We're told that Alid is younger than Gwilym. So this person is younger at 13 and a half. Gwilym is exactly 16. Okay, so I can identify those dots there, those scatters, and then it says, complete the following statements. A Larry's parents or carers pay how much? So a Larry identified this one here. A Larry is 20 quid. Then Harriet was the higher one there, 30 quid. Complete each of the following statements. Gwilym is how many years and how many months old? So Gwilym I identified as this one. Sorry, Gwilym I identified as this one. So that is exactly 16 to the day. So that is going to be 16 years and no months. And then Alid, we identified as the younger one. So Alid is this guy here. Now he is exactly in between 13 and 14. So the correct wrong answer here would be to say 13 years and 5 months. So I have a few problems with my visualizer. Sorry if it's stuttering about. It's stuttering here as well, but it's usually okay. Now the wrong answer here would be to say 5 months. Now the reason why that's wrong is because you count here 1, 2, 3, 4, 5, and you think, oh, well, it's 5 months. But how many months are there in a year? There's 12. Now, this is halfway in between 13 and 14. So half of 12 months would be 6 months. So that's where I would see most people going wrong there, okay? We're then told that Leakin, his parents pay £32.50 towards his mobile phone, okay? He is the youngest of 3 students who receive that amount towards their mobile phone. So if we look for £32.50, 30, 35, £32.50, 3 places, he was the youngest. So that's Leakin there. Okay, so from there then, it then says how old is Leakin? Oh, we need to go and answer that. So Leakin is 13 years old. It then says, do you think Leakin's parents are right to complain that they are paying too much towards his mobile phone contract each month? You must use the scatter diagram to give a reason for your answer. Well, he's paying £32.50. How many people are paying more than Leakin? One person. There's 2 people paying the same amount. How many people are paying less than Leakin? 1, 2, 3, 4, 5, 6, 7, 8 people are paying less than him. Okay, I pay less than that as well, so I'd say he is paying too much. So, are they right to complain? I'm going to say yes. There's no reason why you can't say no, provided you give a valid answer again. Check the mark scheme to see what valid answer is being accepted. And I'm going to say only one person pays more compared to 8 paying less. Okay. Okay, then over the page, we've got a recipe to start working out, changing between grams and millilitres and all sorts. So they've given us two things to use here. So we've got 1 ounce is 28 grams, 1 pint is 568 millilitres. So we're then asked to go and use the conversions from there to go and work them out down here. Okay, so 4 ounces of butter. Now, I'm going to try and use my space wisely here. So the butter, we know that 1 ounce is equal to 28 grams. And I want to change from ounces here into grams. So 4 ounces, I'm not going to do it in one step because I don't know it. I'm going to just double it first to get 56. And then to double it again give me 112 grams. So it'd be 112 that goes there for the butter. The next thing I've got is 3.5 ounces of flour. Now, I've pretty much done all the work there for working out the flour. I know that 1 ounce is equal to 28 grams. So half an ounce would be half of that. So it would be 14 grams. So to work out 3.5 ounces, I want to do 4 ounces, which is 112 grams, take away half an ounce, which would give me, what's that, 14 grams here. That would give me 3.5 ounces. So 112 take away 14. Well, if we do 112 take away the 12, that would be 100. Still 2 to go, so that would be 98 grams. So 98 grams of flour. We've then got 3 pints of milk. So 1 pint is equal to, was it 568? Now again, double it in the first instance. And we're going to get, I'm going to partition that over here actually. So 560 and 8. Double of 500 is 1,000. 120 and 16. So that is going to be 1136. So 1136 millilitres. If I add those together, 2 pints and 1 pint makes 3 pints. And then 8 add 6 is 4. 14, sorry, carry 1. 6 add 3 add 1 is 10, carry 1. 5 add 1 is 6, add that one there. 7 and 1. So I make that 1,704. And then grams of cheese. So we've got 9 ounces of cheese. Okay, so from there then, we've already worked out 4. So if we do 4 ounces is equal to 112 grams, then 8 ounces would be twice as much, so it would be 224. And then we know that 1 ounce is 28. So if we add together the 8 ounces and the 1 ounce, that will give me 9 ounces. So, 12, 5, 3. So I make that 300. Have I done that right? No. It's 2, isn't it? There's no carry there. 252 grams, okay? Okay, then question 7. It says Macy and Gareth are planning a bike ride. They have a map scale of 1 to 50,000. Gareth suggests a route that measures 48 centimetres on the map. Macy says she could cycle up to 13 miles. Will Macy be able to cycle the route Gareth has suggested? You must show working and give a reason for your answer. Okay, now, it was the first 3 lines that even if you find a question like this really, really tricky and really, really hard, the first 3 lines gives me enough to go and do some maths and gain some of those 5 marks there, okay? I know that 1 to 50,000 is the ratio here, okay? Now, what that means is that 1 centimetre on the map is equal to 50,000 centimetres in real life, okay? Now, what I'm going to do is I'm going to actually start to get that down into a much more manageable number and not deal with centimetres in real life. I wouldn't measure the distance from Newport to Cardiff as 50,000 centimetres. I'd measure it in kilometres or miles, okay? So what I'm going to do is I'm going to divide by 100 to begin with to turn that into metres. So that would be equal to 500 metres. And then I'm going to divide that by 1,000 to turn this metres into kilometres. So 1 centimetre is equivalent to, there we go, saved, to 0.5 kilometres. Now, what I want to do is work out how long 48 centimetres is. So 48 centimetres, I would times that by 48. That means I would times this by 48. Okay? Now, from here, I want to work out what is half 48. So 48 would be 24 kilometres. Okay? So I'm going to say here that distance is equal to 24 kilometres in real life. Now, the problem here is Macy has told us that she can cycle 13 miles. So you need to know this conversion. 5 miles is equal to 8 kilometers. Okay, that's the worst 8 I've ever drawn in my life. Hopefully that's a bit more clear now. Okay, that is a conversion you're expected to know. We've just gone and found out that is 24 kilometers. What do I do to 8 to get to 24? Times by 3. Do the same to both sides. Times by 3. So the distance is 15 miles. Okay, so the bike ride is 15 miles long. Okay, now as ever with a numeracy paper, you can say yes or no for this. I'm going to say no. She said she can cycle up to 13 miles. So in my case, I just say, look, if I said I'm going to go up to 13 miles, I'm not going 15. However, in the mark scheme, it does say, yes, she could push herself to 13. And I have been out on bike rides with friends who say, yeah, you're doing it. Just get on with it. Okay, so as long as you argue the point here, you should be all right. Okay, so I'm going to say, no, 2 miles too long. 2 miles longer than Macy said. Take away 13 that she said she could do. Okay, next question. It says, the concrete base of Miss Morgan's new bungalow is shown below. The concrete base of Miss Morgan's bungalow is 0.2 metres thick. Calculate the volume of the concrete base you must show all your working. Now, hopefully looking at this, you'd see this and recognise that as a compound area question, even though it's asking me to work out volume. To work out volume, I need to know what the area of this guy is, and then I need to times it by the thickness of it, okay? So the first thing I'm going to do is work out area A, then I'm going to work out area B, and then I'm going to add them together, and I'm going to times it by 0.2. Now, common mistake that people do with this type of question is they get the wrong dimensions. These are the dimensions of rectangle A. It measures 5 by 4. Okay, so I'm going to write here A, 5 times by 4, which equals 20 meters squared. For area B, and again, people get the dimensions wrong. Now, it was very hard to get the dimensions wrong here, but this is where people go wrong. They'll correctly identify that this length is 15, and they'll incorrectly identify that this green length here is 20. It's not. The 20 is the orange and the green bit. We want just this bit here. Now, I know 20 is all of this, but I don't want this 5 here. So this is 15 meters. Okay? So area B is 15 times 15. 15 times 15 is 225 meters squared. If you're unsure on that, there's loads of different ways you could do it. I'm going to show you a very quick, easy way which you could do using the box method by doing 10 times 10 to get 100, 5 times 10 to get 50, 10 times 5 to get 50, 5 times 5 to get 25. Add them together, you get 225. The total area then is equal to 225 plus 20, which equals 245 meters squared. Okay. Now, to work out the volume, I want to do 245 times by 0.2. Now, I'm going to use my understanding of fractions, decimals, and percentages here to say 0.2 is the same as finding 20%. So I'm going to say 10% is equal to 24.5. So 20% would be double of that, which would be 49 meters cubed. Okay, so that was the answer for that one. Oh, I had loads of space on the other side as well. 49 meters cubed. Next question says, Mr. Graham is building a garage. The concrete mixer holds a maximum load of 6 meters cubed of concrete. There is a fixed standard charge of 35, delivery charge of £35 per load. The concrete costs 45 meters cubed per meters cubed. Mr. Graham orders 2/3 of the maximum load of concrete for the base of his garage floor. So we need to go and work out 2/3 of the maximum load. So 2/3 of 6 meters cubed, that would be 1/3. If you find a third of something, you divide it by 3. It would be equal to 2. So 2/3 would be equal to twice as much, would be equal to 4 meters cubed. I then have to pay £45 per meter cubed. So I want to do 45 times by 4. So I'm going to do that by doing 45 times by 2. I'm going to double it to get 90. So to times by 4, it must be 180. So we're going to pay £180 for this bit. I'll just highlight it to match them up. Okay, that's how much the concrete costs. Then I've got to pay that delivery charge. So it's going to be 180 plus the 35. Nothing add 5 is 5. 11, 2. So the cost is 250. Question number 9. It says, Olga took out a high interest loan for £400. She paid back £49 per month for 20 months to clear the loan. Calculate the total interest that Olga paid as a percentage of the original loan. Now, this is quite a tricky question. It's not an easy one. First of all, we need to work out how much Olga repaid. So we want to do 49 times by 20. Too hard to do it is times by 20, but double it, times it by 2 to work out that's 98. So times by 20 must be 980. Then we need to use a formula to work out the percentage of the original. We want to do 980, so what the cost was, take away the original amount, divided by the original amount, and then times by 100. Okay? Now, what I'm going to do is start to work this out. 980 take away 400 is 580 divided by 400. Now, bear in mind we haven't got a calculator here, so what I need to do now is just keep cancelling down that fraction or simplifying it. First of all, I'm going to divide top and bottom by 10 to get 58 over 40. I'm then going to divide top and bottom by 2 to get 29 over 20 times by 100. Now, I still don't know what that is, so I'm going to do something we're not supposed to do with fractions, but because I'm then going to times it by 100, it's no problem. First of all, I'm going to divide top and bottom by 2 to get 14.5 over 10 times by 100. And then I'm actually going to divide that by 10 now. So 14.5 divided by 10 is 1.45, which I then times by 100. And 1.45 times by 100 is 145%. So she's paid 145% too much, which is an awful lot to pay on a loan. Over the page, it says blank page, please do not write on this. And then we have got a question on some bearings. Now, these aren't bearings as we would normally do using a protractor. The reason why that's not the case is because we are told that this diagram is not drawn to scale. If we're ever told that with bearings, they're expecting us to pick out these things here, which are parallel lines. Okay. Now, the main skill they are looking for here is to identify that we are spotting what we call C angles, okay? If we spot C angles, we should know that this angle and this angle add together to make 180, so that would be 28 degrees. If I add 8, I get 160, then add 20 would give me 180, and I can do the same with the C angle over here. There. What do I add to 170 to make 180? So just 10 degrees, okay? So that's what those two angles are there. The next most important thing to remember when we're talking about bearings is, okay, we're looking for alpha. So we're here. When it says from Gwyndir, that means we are here. When I measure a bearing, I measure it clockwise, and I measure it in 3 figures, and I measure it from north. So I'm looking, let's get my pencil, to measure from the north line, keep coming round and round and round until I get to that line there. I want to know what this angle here is, okay? Now, I know this side is 170, so I can work this out because I know that the full distance around would be a circle, which would be 360, so I want to do 360, take away 170. Nothing take away nothing, 6 take away 7 I can't do, 16 take away 7 is 9, 2 take away 1 is 1, so 190, okay? The next one underneath it says, what is the bearing of cum from alpha? Okay, so if I'm from alpha, it means I'm here. I'm looking for cum. So cum is up here, so I measure clockwise, come round and round and round, keep coming round, there, stop. Okay, now there's 2 ways of doing this. I can either try and work out what this angle is by doing 360, take away these 2 angles, or I can say that I've come back from 360 28 degrees, which is definitely the easier way. So I want to do 360, take away 28. 360 take away 20, give me 340, take away the 8 would be 332. So that should be an answer there. Okay, next bit of this question doesn't involve the bearings, so I'll pop those away. It says the area of the land covered by the 3 villages is 200 kilometers squared. The total population of the 3 villages is 8,400 people. What is the population density of the 3 villages? Give your answer in population/km squared. Now, I always teach my classes to use the following triangle. If you've not been taught it, you can work it out from what they've told you in the question, okay? So it's DA on the bottom, and then P there. Stands for population, density, area, okay? PDA. Now, we're told here that we want to do the population, so that's the number of people, divided, tells you there, slash, that means divided by the kilometres squared. So it's told us the calculation anyway. They've asked me to go and work out what the population density is. So my triangle would tell me to cover up the D to work out density is population divided by area. But it tells me that anyway in the question. So you can usually work it out from there. So my density would equal 8,400 people divided by an area of 200 divided by 2 is 42, and that would be population slash km squared. Population divided by kilometres squared. Part 2, it says the populations of Cum, Alpha and Gwyndir are in the ratio 3 to 4 to 5. Calculate the population of Gwyndir. Now we're told here that this is the total population of all 3 villages. So there's no nasty tricks here. It's literally just a nice simple ratio question. So what we need to do is work out the total parts. So total parts would be 3 add 4 add 5. So 3 add 5 is 8, 8 add 4 is 12. So 12 parts. We now do 8,400 divided by 12. Ignore the zeros. How many 12s go into 84? 7. So it's 700 for one part. And we're asked to go and work out Gwyndir. Now, Gwyndir was the third one here, 1, 2, 3. So it's the third one there. So I times it by 5. So 700 times by 5 is equal to 3,500 people. Okay, then the next question, question 11. Says Kingsley invests £3,000 in an account that pays 2% compound interest per annum. He does not make any further payments into his account. He does not withdraw any money from his account. How much money will Kingsley have in his account after 2 years? Now, the key word here is it's compound interest. So that means its interest gets added to the interest for after 2 years. Now, the issue with this is that you're usually told a formula where you do something like £3,000 times by 1.02 to the power of 2, and it would just do that for you in your calculator straight away. We haven't got a calculator. This is non-calculator. That way is definitely an efficient method, but no use when you haven't got a calculator. So the way I did this was I said money is 3,000. I want to go and work out what 2% is. So I'm going to work out 10% as 300, 1% as 30, 2% as 60. The end of that year, I would have the £3,000 plus 2% interest. So I get 3,000. Okay. The next thing I've got now is my new year is £3,060. So 10% of that, because I haven't got a calculator, is 306. 1% is £30.60. 2% would be double of that, so £61.20. And then I want to add that on. So I'm going to write here £61.20 and add those two together to get 20 will be on there, 1, 12, 1, 3, to get £3,121.20. Part B, now we're quite near the end of these, so just watch out for these. They're not as simple as they're going to look if they're page 21. Kingsley buys a portable Bluetooth speaker. The speaker has been reduced in the sale by 20%. He pays £72 for the speaker. What was the original price? If you ever see the words original price, we're always talking 100%. Okay? 100% is the original, but we know that it has been reduced by 20%. So we want to take away 20%. That is equal to the price that he pays. So that is equal to £72. 100% take away 20% is 80%. That is equal to 72 quid. I need to get that back to 100. Now, there's a couple of ways I could do this. I could times both sides by 10 to get 800%, then divide by 8. To get 100%, I'm actually going to divide this by 8 to find 10%. Whatever I do to one side, I must do to the other. How many 8s go into 72? 9. So 10% would be equal to 9 quid. So 100%, which is the original amount, would be equal to £90. So the price of the original speaker was £90. Okay, question 12. Quite a tricky one, this one, because you've got to try and visualise what's going on. Now, I've already spotted what this question is asking, because it tells me this bit here. Correct the nearest centimetre, correct the nearest centimetre. They told me in bold here as well. Okay. It says, Michelle owns a cafe. She stacks mugs, coffee mugs shown in the diagram below. Michelle measures that the height of each coffee mug as 12 centimetres. Correct the nearest centimetre. Each is stacked creates 4 centimetres extra in height. Okay, so these are effectively 4 centimetres in height, 4 centimetres in height, and this would effectively be 12 centimetres. Okay, now from here, the first thing I would do is go and work out what the upper and lower bounds of this is. That's what this question is on. It's saying, right, can you go and work out the upper and lower bounds of that? Correct the nearest centimetre would mean 1 centimetre is divided by 2 to get 0.5 centimetres. You add that on and take that off to find the upper and lower bound. So the upper bound would be 4.5 centimetres. The lower bound would be 3.5 centimetres. Similarly here, we're going to go and work out the upper and lower bound by adding on and taking off 0.5 centimetres again. So that's 12.5 centimetres and 11.5 centimetres. Okay? Now, the best way that I use to describe this, so if we go and actually look what the question says, it says, can Michelle be certain that she will be able to fit one stack of 7 coffee mugs between the 2 shelves? You must give a reason for your answer. Let's just work it out without worrying about upper and lower bounds for a moment. Okay? Now, if I've got a mug 7 stacks high here, or 7 mugs in the stack, I'm going to have my base cup, which is going to take up 12 centimetres, and then I'm going to have 1, 2, 3, 4. Now that's 1, 2, 3, 4, 5 in the stack. 6, 7. I've got 1, 2, 3, 4, 5, 6 gaps here. So I've got 6 lots of 4 centimetres. So this would be 24 centimetres plus 12. So if there was nothing to do with upper and lower bounds, 24 plus 12 would tell me that it's 36 centimetres. Okay? Now, what I want to do is work out here what is the worst case possible scenario. Now, my best case scenario, so thinking like an optimist and a pessimist. So an optimist thinking, oh yeah, I'm sure it'll be fine, and a pessimist going, oh, I don't know, we need to be careful here. We know that this is exactly 39 centimetres. It's exactly 39. Okay? Now, if I was thinking like a pessimist, I would say, well, what if the cups are a bit bigger than I'm giving them credit for? So what if they're 12.5? And what if this one, the gap was 4.5? Okay, the optimist would think the total opposite way around. They go, oh no, I'm sure the cups are a bit smaller than they've actually said. I'm sure there's not as much gap between them as we said. So what I need to do, thinking like the pessimist, is do the base cup. So that's 12.5. And add 6 lots of the gap. So the gap being as big as possible times by 4.5. Okay. 6 times by 4.5. I'm going to show you a trick to work this out. Well, it's not really a trick. It's like a clever way of doing it. 6 times by 4 is 24. 6 times by 5 is 30. So 6 times by 4.5 must come bang in the middle of those two there. So the number in the middle there would be 27, because the distance is 6. Half of it would be 3. So you can either add 3 onto 24 or take 3 off there. There's other ways to work it out, but I thought that's quite a good way of working it out. Okay, so I need to work out now 12.5 add 27, which I'm going to write here actually. put those together, and we're going to get 0.593. So I'm going to say, can we be certain? Can she be certain? No. It could, and that's the keyword here, it could be as much as 39.5 centimetres. Okay? Over the page, number 13 says, this year 50 runners took part in a 5-kilometre race in Brecon Beacons. All 50 finished the race. The cumulative frequency diagram below shows the times taken by the number of runners to finish the race. What is the modal group? Now, the modal means the most popular group. What group there is the most popular group? Now, we know that mode means the most number of people. So I'm looking here at frequency, meaning number of. Cumulative just means it's a running total. And I'm looking for the steepest line here. Now, this steepest line here, that tells me that I've got 27 people who finished it there. Well, there's 50 in total, so there's nowhere else going to be bigger than 27. And that is in the first time group, which is 20 to 25 minutes. Okay, so we're looking for the steepest line to represent the modal group there. We're then asked for part B. It says, is it certain that the last runner's finish time was 45 minutes? Sorry, the last runner's finish time was 45 minutes. You must give a reason for your answer. Now, we know here that there is 50 people in the race. Last one there is 50, but this represents a group between 40 and 50. Okay, so the answer is no, because they could have finished at like 40 minutes and 1 second. So I'm going to say they finished between 40 and 45 minutes. Okay, so they could have finished on 45 minutes, but we can't be certain they were exactly 45 minutes. Okay, we're then asked here, it says the organisers hoped that 80% of the runners would finish in 30 minutes. Complete the following two statements. What percentage of runners finished the race within 30 minutes? So all I need to do is go and find 30 minutes on my graph. There, 30 minutes. Draw a line up until I hit the graph. And I can see there that it's 35 runners. Okay, so I know that 35 runners out of 50 completed it within 30 minutes. I want to find that as a percentage. Times that by 2, times that by 2, 70. So they're wrong. Okay, 70% of the runners finished within 30 minutes, not 80. 80% of the runners finished within how long? Well, what I need to do is find 80% of the number of runners. So 50 in total. So I'm going to say 80% of 50. 10% would be 5. 20 would be 10. 40 would be, so that's 2. 40 would be 20. 80 would be 40 runners. So I'm looking for 40 runners. I come along here and I read down 35. Okay, so 80% of the runners finished within 35 minutes. And then finally it says, last year the median time to finish was 26 minutes. By how many minutes was the median time better this year? You must show your working. So median is the middle person. There was 25 people. Sorry, there were 50 people, so the median person is the 25th person. So I come over here, I read off from my graph. Now, if I move the camera down and I focus on it, can you see that that has slightly gone on from there, ever so slightly? Now, this is what you need to do. You either make it onto this line or this line. Now, it's much closer to this line, so I'm actually going to come back a tiny, tiny little bit there. Okay. So let's come back up and focus. So you can see that I am one little square back from 25. Now just be careful, work out your scale, very easy to go wrong here. That is a jump of 5 in 10 little squares, so each little square is worth 0.5. So this is 25 take away 0.5, which should be median time of 24.5 minutes. 24.5 minutes this year. So, question, have I answered it? By how many minutes was the median time better this year? So that is going to be 26, take away 24.5, which would be 1.5 mins, or 1 minute and 30 seconds. Right, final question. It says, there are two entrances to the stadium, to a stadium, north entrance and south entrance. An entrance, at each entrance, 3,000 people queued to pass through security. The length of time each of these people spent in the queue was recorded. The box and whisker shows these results, okay? Now, the first thing I'm going to do is just label parts of a box plot. This is the minimum amount of time that it would have taken. This was the maximum amount of time. This middle line is the median. This lower one, or this one here in between, is called the lower quartile. And this one here, in between the median and the max, is the upper quartile. Okay? Now, because we're dealing with quartiles, this represents 25% of people between each line here. So this really small little bit here represents 25. This larger bit here, also 25%. And this one here, this really long bit here, 25%. Okay? Now, those things are really crucial to being able to answer these questions. Whereas for question A, it says, at the north entrance, so we're working with the top one, how many people had to queue for more than 44 minutes? So we look here at the scale, there's 40, two little squares. Yeah, each little square is worth 2, is 40. It's this bit of the diagram that they want me to work out. Well, I've already identified that from explaining these thoroughly to begin with. That's 25% of the population, so 25% of 3,000. 50% would be 1,500. Half of that would be 750. Okay, so it's 750 for that answer there. Over the page, oh, hold on. There we go. Over the page, we've got, for the south entrance, calculate an estimate for the number of people who had to queue between 40 and 60. So between 40 and 60. So how many people are in this block here? Now, if I take a look at that block as a whole, we know this amount here is 25%. Okay? Now, this block here, I've split it into 3 blocks, and I've got 2 blocks coloured. So it's 2/3 of 25%. Now, I've worked out 25% already. Okay? So I'm going to say it's 2/3 of 25%. So that's 2/3 of 750. Okay? So what I want to do to find 2/3 of something is find 1/3 by doing how many 3's go into 750. 3's into 7, 2 remainder 1, 3's into 5, 5, 3's into 0, 0, 250, and then doing 250 times by 2 to get 500. There are 500 people that took that long as an estimate, okay? We don't actually know. They could have all taken this long. They just measured it between this long, okay? And then finally, for part C, again, as true always with a numeracy question, it says, at which entrance did the security team seem to be more effective? So that means getting people into the stadium quickly. So the key word there being quickly. Who was quicker? Now, I could tick either of these already, I can tell you that, as long as I actually go and mark, or not mark, as long as I actually go and give an answer and give some clarity as to why I'm actually choosing that, okay? Now, they both had the same minimum time, they both had the same maximum time, they both had the same median time. So all of those things are irrelevant. So we're looking now at the percentages of people. If I look here, 25%, 25%, 25%, 75% of the people here were quicker than 44 minutes. If I look at the same here, 25, 25, 25, 75% of the people took 60 minutes. So for me, the north entrance was way more effective, as 75% of people were through by 44 mins compared to 60 minutes south entrance. Okay, that is the end of the paper. If that was useful, please could you hit the subscribe button, and you'll get first access to any more videos that I release. I hope that was useful. Thank you very much.